Part of what QSET does, apart from just designing, especially doing things like Lunabotics and QSET, is community outreach. So we want to go out into the community. We want to go to Kingston, and we go to the schools. We want to talk to the kids about space and engineering. And depending on how old the group of kids is, we can do certain activities, things like painting and coloring, up to design, and even playing with robots, and even doing some programming. I recently went to the Boys and Girls Club, just located really close to the school here, and we painted with them and we talked to them about space, and they were all really excited. They all got really into the aliens and into the rovers, and we're all asking things about space and the moon, and we got to explain to them what rovers were about and why rovers have, solar panels, for example, and what kind of wheels they use, things like that. And I think they really got into it. It was really interesting, and I think, kids especially have really malleable minds, and I think that this is one of those times where talking to them about space was just really helpful, and I think it really got them all inspired. We're probably going to go back to that school again and do some more activities with them because we had lots of fun. We even got art from them, actually, so that was nice.
So far, since last time we talked, we have completed the frame, attached the conveyor frame onto that frame. We've made the motor mounts for that conveyor. We've done the wheels. We've also done a training session for Inventor. So everybody on the team can now do our 3D modeling. So for the final model, we'll have a very nice 3D model to work off of. We've made a parts list and ordered all the parts for that final model. So we're just waiting for all that stuff to come in to be able to start doing some of the frame building for that section. We've also done the scraper, made the attachment to the frame for the scraper, which is like the bucket that digs. And we've made the attachments for the actuators. We're currently making the supports that will be holding the actuators to the frame itself. That's what allows us to pour the bucket into the conveyor reservoir. We're currently getting the positioning set up so that we can make that reservoir, which will be allowing us to transfer the regolith from the scraper into the conveyor system.
Since the last update, the electrical team has been working to design a variety of the subsystems we will be using to be implementing on the robot. The major considerations we had to do at the start was where we were going to order all the components and selecting the components and finding suppliers to receive our components. Major things we looked at, first of all, was obviously the motors. The motors are required for us to move around, so we picked up a couple different motors from local sources. We tested the current, the voltage, the power considerations, and decided that optimally we were going to use a 24-volt high torque motor. The next major consideration we had to get was the motor controllers. So what those are is that's what enables the motors to be able to turn around, move at different speeds, so we had to select those. We've ordered 2 of those now, so we will be using 2, 1 for each side, and we also ordered a third one which will control the speed of the conveyor belt. Next off, we ordered some safety and security stuff, so we ordered a kill switch, which is basically it's just a big red button which you can run up and hit to make the robot stop in its tracks if we ever needed to. We also ordered some current sensing and voltage sensing equipment, as well as a master current breaker, so if the current ever got too high, it'd break and the robot would shut off, which is optimally what we want to avoid the components getting destroyed. We also ordered some push buttons, so our robot, when it's going to be backing up, it's going to be hitting the wall to unload, so we want some buttons on the back of that so when it hits the wall, it'll know that it's there so it can shut off. We also ordered a gyroscope, so when we're doing the autonomous work, it'll be able to detect how it's tilted, so it'll be able to maneuver the obstacle course better. And we've had a variety of teams working on all these systems. Finally, for power, we ordered our batteries. We got our battery chargers in, and they're working great. And we're working on designing our 24 to 12 volt buck converter, and it seems to be working pretty well too. Overall, Alex designed a whole bunch of the systems. Our components are just rolling in every day this week, and we hope to be able to start putting everything together into our prototypes for the future. It's looking pretty good for Alec, and I think we're definitely on track to finishing for the competition.